Let's do some homework. We've got a couple ACT problems here. Number one, sales for a business were $3 million more the second year than the first. And the sales for the third year were double the sales for the second year. If sales for the third year were $38 million, what were the sales in millions of dollars for the first year? So we have 3 years that we're talking about. Unfortunately, we don't know the first one. So whatever the first year is, that's kind of a question mark. The second year is going to be, it says it's $3 million more the second year than the first. So that's kind of like some number plus 3. And then the third year is double whatever we had the second year. So mathematically, that would basically be saying we need to take, double or 2 times whatever that starting number was plus 3, and that should come out to be 38. It's sort of natural to then go ahead and call that question mark sort of an x. So really what we're trying to solve here is 2 times x plus 3 equals 38. That's the algebraic way of working this problem. We can divide both sides by 2 like this, and that gives us a number plus 3 equals 19, and then we can subtract 3 from that, and we get the answer of 16 years, which is what letter A is. So that's the very algebra way of doing it. You could have just used the answer choices to guide you, and you can just kind of take this, if you take the number 16, which is the first answer choice, and then you realize, oh, I'm supposed to add 3 to that, that would give you a total of 19. And then all of a sudden, the third year, you're supposed to double it. Well, 19 times 2 would be 38, and that's exactly what it's talking about. So it wouldn't be hard to just use the answers to help you answer that question as well. Number 2, very wordy, but not really much going on here. If you've had geometry, you may have done the problem where you learn to do what we call bisecting an angle with a compass. And so this is walking through the steps of doing that. It says we start with this, in the figure below, ray EF, so that's this center arrow, or ray, was constructed starting from rays ED, which is that line in that way. So basically we start off with this angle here, angle DEG, and basically then they run this through there and they describe the process of how they do that. But what you'll notice is a lot of words such as equidistant in there, and essentially that's going to come out to basically understand that it says the measures of angle DEF, which is this angle, and compare that with the measure of GEF, which is this angle. Those things are equal, and you can pretty much trust your eyes on that picture. But with all the words that they're talking about equidistant, again, that's running through a process called bisecting an angle that hopefully you did at least one time back in geometry. I know it's been a while. Bisecting an angle. Probably some YouTube videos on that if you want to look it up. Number 3, the area of a circle is calculated by A equals pi r squared. And the circumference is calculated by C equals 2 pi r. So remember, area is the amount of space it sort of takes up on a flat surface, and then circumference would be the distance around it, kind of a perimeter. It says if the area of the circle is 25 pi, what's the circumference? Well, there's really not much to these equations. You just need to know what the r is. As soon as I know what the r is that produced the area here, I should be able to use that same r and just plug it into the circumference over here. Essentially what we're setting up here is kind of just an equation. The area, so I'm using A equals pi r squared, but they just told me the area was 25 pi. So if I set up 25 pi equals pi r squared, you can solve for r if you want to, but it's also not very hard to understand that in this case, r is just equal to 5, basically the square root of 25. So r is going to equal 5, and now we can just take that and plug it into the circumference. So if c is equal to 2 pi r, then obviously the circumference is going to be 2 times pi times 5, and that's just 10 pi would be a decent answer there. That's a good question just to remind you about those formulas. That's the only reason I wrote that question, is just because you guys need to be ready for area and circumference, and that was just a basic one. All right, let's move on. All right, so a variety of problems back here. Number 5 and 6 just need to continue practicing the situation that comes up when you're doing quadratic formula. It turns out when you look at number 5, the issue here is the square root of 100. The square root of 100 is just plain number 10, as in 10 times 10 gives you 100. So this thing reduces down to be x equals 5 plus or minus 10 all over 2. And there's no reason we should stop there. We just have numbers, so we might as well do this. 5 plus 10 is 15, and we're going to divide that by 2. That comes out to be 7.5. Furthermore, if you do the minus version of that, 5 minus 10 divided by 2, 5 minus 10 is negative 5, and then divide that by 2, and you're going to get negative 2.5. So 7.5 and negative 2.5 are your answers to that. I guess I should put x equals on both of those. So x equals 7.5 and x equals negative 2.5. Number 6 is just a little bit more complicated because the square root of 54 doesn't really, it's not a perfect square number, so it doesn't have a simple square root. We need to break that number down. So it turns out we can break up the square root of 54, and what we're looking for is the list of perfect square numbers. What's a perfect square number that goes into 54? Well, you might remember that 54 is 9 times 6, and the beauty of that is that square root of 9 is the number 3, so we have 3 square root 6. So here's where we are then. We're looking at 21 plus or minus the 3 square root 6 all over 6. And now we can shrink these numbers, is what I like to call it. I just noticed that this number 21 and the number 3 and the number 6, those can all be divided by 3. I'm just kind of noticing that, honestly. Just thinking through my multiplication facts and division facts. 21 divided by 3 is 7. 3 divided by 3 would be 1, so it kind of cancels out, leaving just the square root of 6. And then 6 divided by 3 is 2. And I'm going to stop there. I could go get decimals with a calculator if I wanted to, but the instructions said to simplify. And this one, that's just as far as it really simplifies. Anything after this would be decimals because it's an irrational number because of the square root of 6. All right, 7, 8, 9, and so on. These are those problems that we haven't been trying to understand this concept of sort of a reverse double distribution. If you think of number 7 as being the answer to a double distribution problem, the question is, what was the original question? The idea here is we're looking for two numbers, and they have to multiply to be, in this case, 20, and add to be 9. So two numbers that multiply to be 20, but add to be 9. And I hope what comes to mind is the numbers 4 and 5, or 5 and 4. And that would be your answer there. X plus 4 times x plus 5. Or the reverse of that, just to show you that the order isn't what's important. It's the numbers themselves. And that's the final answer, number 7. Number 8, same concept. Think for yourself for a second. We're going to ask ourselves, what two numbers are going to multiply to be the positive 20, but add to be positive 12? Now, in case you're struggling with that, don't be afraid to just grab a calculator and go, okay, well, 20 divided by 1 is 20, 20 divided by 2 is 10, 20 divided by 3 is a decimal, 20 divided by 4 is 5, and that's the end of the pairs that make 20. So which one of those pairs is going to add to be 12? Well, clearly it's 2 and 10, or 10 and 2. Doesn't matter what order you put them. Both positive, though. Number 9. Two numbers that are going to multiply to be positive 18, but add to be negative 9. the trick on this one is to have two numbers that multiply to make a positive number but add to be a negative number means they're both going to need to be negative. So if you think about the number 18, 18 either is 1 times 18, which doesn't make 9, 2 times 9, which also doesn't make 9, or 3 and 6, which can make a 9, as long as they're both negative in this case. And we're done there. Remember, the order doesn't matter. Number 10, two numbers that multiply to make positive 5 that add to be negative 6. Same situation as question 9. They're going to both need to be negatives for that to work out. The number 5 is not a very interesting number. It's only 1 times 5, and so that's got to be our choices here, but we do need to check and make sure that makes sense. Sure enough, negative 1 times negative 5 is going to add, or multiplies to be positive 5, but adds to be negative 6, so we're done there. Number 11 and 12. So all I did to you here was just wanted to stretch you a little bit, since I was hoping you'd watch this video. X to the fourth is going to cause us to have to write these two guys like that. Hopefully you agree x squared and x squared would make an x to the fourth. And at this point we call this actually quadratic-like. Even though x to the fourth is not really quadratic, we still look at what two numbers multiply to make 12, add to be 8. And those numbers are 6 and 2, or 2 and 6. And that's the end of that problem. Number 12, trying to factor this. Again, because of the x to the fourth power, and I hated to kind of do that to you, but I also know that the ACT and heck, the final exam for the semester might have problems like that on there, so might as well get that out in the open. Hopefully it makes sense. X squared times x squared would make the x to the fourth. And then multiply to be 5, but add to be negative 10. Well, that would both be the same number, negative 5, like that, and that would be your final answer. Although there is something clever you can do. Since they both came out to be exactly the same, you can shorten it up as this answer if you want to. Anyway, a couple challenging problems there at the end, but hopefully all okay. Glad you did your homework. Hope this helped.